Welcome back to the channel, Calculus Peeps. We are going to take notes on section 4.3 now, increasing and decreasing functions, as well as the first derivative test. So in this video, we're going to hopefully be able to determine when a function is increasing or decreasing. Visually, I can not worried about it, but without a graph, can we determine functions increasing or decreasing by looking at the equation and locate the relative extrema, the maxes and mins, which last class we did absolute extrema. Now we're looking at relative extrema, so just the hills and mountains, not necessarily the endpoints. Okay. So take a minute to pause the video, copy down the screen. Now, on what intervals is this function increasing / decreasing? So it's increasing when the equation, I guess you can think of as going up. So at this chunk and at this chunk. So those are the two intervals where the function's increasing. Those intervals would be -2 to, I'm just going to call that 1 point, let's just call it 1.5. I know it's not. And we're going to union, in other words, combine that interval with another interval, which is, we're going to say 3.5 all the way to, let's just assume this thing keeps going up to infinity. So that is where the function is increasing. The function is decreasing all the way up until -2. So from -infinity all the way to -2. And then it starts decreasing again right here. So I'm going to union that with 1.5 to 3.5. So the function's increasing in the green and decreasing in the red. What can we say about the value of the derivative on those intervals? So if you were to take the derivative and plug in any numbers in the red, your derivative would come out to be negative, meaning your slope is negative. So if your function, where your function is decreasing, the slope is negative, which means the derivative is negative. Where it's increasing, the slope is positive. Which makes sense from algebra 1. Which means the slope, which is the derivative, the derivative is positive. Okay. What can we say about the value of the derivative between these intervals? So at these points right here, what can we say the derivative is? At those points, the derivative is 0, or the derivative does not exist. In all of these cases, the derivative is 0, but if you had something like this, the function's increasing here, decreasing here, and at that point in the middle, the derivative would not exist. The derivative wouldn't be 0 there. It would be a DNE when you have sharp points. So based on a graph, we know when it's increasing or decreasing because we can visually see it. What does that mean about the derivative? Well, it's the same thing as asking what does that mean about the slope? So the slope's negative where it's decreasing and it's positive where it's increasing. And in the places where it switches, we have our relative maxes and mins. Okay. So determining the intervals, to find out where the function is increasing or decreasing, we're going to need to find out where the derivative is positive and negative. So these are the steps that I want you guys to copy down. Step 1, find the critical numbers. Remember, that's where the derivative is either 0 does not exist, but those values need to exist in my original function. Those critical numbers, again, are where the derivative 0 does not exist. So those are the only places where it's not positive or negative. So those are going to define our intervals. So like in this example here, -2, 1.5, and 3.5 would be our critical numbers. That's where our derivative is 0. Everywhere else, the function's either increasing or decreasing. So use those critical numbers to define our intervals. Then to find out whether the function's increasing or decreasing, we're going to calculate the value of the derivative using a test point. So if I come back up to here, if I know these are my intervals are -2, 1.5, and 3.5. If I plug in a number less than -2, if the function is decreasing, so I should get a negative value. If I plug in a number between -2 and 1.5 into my derivative, I should get a positive value, which means my function is increasing. And if I plug in a number between 1.5 and 3.5, I should get a negative value because my function is decreasing. And if I plug in a number bigger than 3.5 to my derivative, I should get a positive output, which means my function is increasing. If you didn't catch that, we're going to do that with some examples, but that's what step 3 is. Plug numbers into the derivative to find out whether it's positive or negative. So if we plug in a number into our derivative and it's greater than 0, which means positive, the function's increasing. If the derivative is less than 0, that means the slope is negative, so the function's decreasing. So that means the slope is positive, and this is when the slope is negative. So it's going to look like a sign chart that you guys may have seen in pre-calc for stuff that you've done in pre-calc. So let's use those steps now to determine the intervals in which f of x is either increasing or decreasing. So the first step is to find the critical numbers. So to do that, just like we did last class, let's find the derivative. The derivative is going to be 3x squared minus 3 times 3/2 x is 6/2 x, which is 3x. And then subtract 1 from the exponent. Now we want to find out when this thing is either 0 or does not exist. So just to start off, this is a degree 3 polynomial. It exists everywhere. And the derivative is a degree 2 polynomial. The derivative is going to exist everywhere. So we just need to find out when it's 0. So the way I would solve this is I'd factor out the 3x, and then I'd get x minus 1 left over. So then I'd get x equals 0 or x equals 1. So those are the critical numbers. Now use that to define my intervals. So let's do this in blue. So I'm going to plug these. I should have done it in green because this is my derivative. So I'm going to plug numbers into f prime. My intervals are going to be, okay, so 0 and 1 is where my derivative is 0. So my derivative is either going to be positive or negative when I'm less than 0. My function is going to be increasing or decreasing between 0 and 1. So I got to figure out what my derivative is between 0 and 1 and 1 to infinity. So we're going to use a test point in each of these intervals. So the first interval right here, -infinity to 0, pick any number less than 0 and plug it into my derivative. So I am going to plug in a number less than 0, like -1. Now, if this value is positive, let's go right up here for a second, then that means my slope is positive, then my function is increasing. If my value is negative, then my slope is negative and the function will be decreasing. So what is f of -1? If I plug it into the derivative here, just know that I don't actually care what the value is. I just want to know if it's positive or negative. So if I plug -1 into here, 3 times -1 squared minus 3 times -1, that's going to be 3 plus 3, which is 6. I don't care that it's 6. What I do care about is that it's a positive number. So it's positive. Now, plugging a number between 0 and 1, I'm going to use 1/2. Okay? If I plug in 1/2, I'm going to have 1/2 cubed minus 3/2 times 1/2 squared. Oh, just kidding. Got to plug it into the derivative, not the original function. I'm glad I made that mistake because that's a question that comes up a lot. I'm trying to find out whether the slope is positive or negative, so I can use the derivative because that gives me the slope. So it's 3 times 1/2 squared minus 3 times 1/2. And again, I really only care if this is going to be a positive or negative number. So let's see. 1/2 squared is 1/4, so this is going to be 3/4. 3 times 1/2 is 3/2. 3/4 minus 3/2 is going to be a negative number. Yes, because 3/2. This is like 0.75 minus 1.5. So it's going to be a negative number, which is all that I care about. And then let's pick a number bigger than 1 in, like, I don't know, 2. If I plug 2 into my derivative, it's 3 times 2 squared minus 3 times 2. 2 squared is 4, 4 times 3 is 12, 3 times 2 is 6. So it's going to be 6, but it's a positive number, which is all that I care about. So that's all I needed. And now I have my answer. Determine the intervals in which my function is increasing and decreasing. So it's increasing from negative infinity to 0 and 1 to infinity, and it's only decreasing between 0 and 1. So f is increasing negative infinity to 0, union 1 to infinity. And it's decreasing just from 0 to 1. So that is what I'm looking for when I say where is the function increasing and decreasing. Okay. All right. Not only can I find out when the function is increasing or decreasing, but I can also find out where the relative extrema are. So the derivative also lets us find relative extrema analytically, and which has a relative min and which doesn't. So this is a relative min. This has no relative min. How would we identify the difference using the derivative? So if I didn't give you a graph, in both of these situations, let's say this is 1, 2, 3, 1, 2, 3. In both of these situations, f prime of 2 equals 0. But in this case, we don't have a min. In this case, we do have a min. They're both critical numbers, but one of them is a relative extreme and one of them isn't. How could we figure that out? And again, make sure you copy that down because it's good to refer back to. So how do we find out where we have relative extrema? That's what we call the first derivative test. So pause the video, take a minute to copy it down. And here it is. So f of x has a relative extrema at c if both of the following are true. The derivative 0 does not exist, so this is like finding a critical point. Now, to find out whether or not we have a relative min or max, or we don't, is if the derivative changes signs at t. So think about this situation. If I took the derivative of this function, so if I found the slope of the function, up until I get to 2, my function is decreasing, so my derivative would be negative. And then at f of 2, the derivative at 2 is 0. Once I get past 2, my function is increasing, so my slope would be positive. When you have a sign change from negative to positive, you have an extrema. In this situation, if I plug in a number less than 2, my slope is positive because the function is increasing. And if I plug in a number bigger than 2, I'm still going to get a positive slope because the function is still increasing. Because there's no sign change, there's no extrema. There's only extrema when you have a sign change. So if your function is going from positive to negative, what do you have? Well, if you're going from positive, you're increasing, to negative, that means you're decreasing. When that happens, that means you have a relative max, right? That's a max. When you're going from negative to positive, you're going from decreasing to increasing. That's when we'd have a relative min. Okay. Reminder, f of c must exist to be an extrema. That's the thing that I said in class last time. you're trying to find your critical points, but where those critical points where the derivative of 0 does not exist, those c values must exist in the original function. And if we also have a sign change, then we have a min or a max. Okay. So this is something we just need to get a lot of reps in, and we'll get better at it. Some of these derivatives are a little spicy, which we like. So it's good to get some reps with this. So step 1, let's find the critical numbers to define our interval. To define the critical numbers, again, find the derivative. So the derivative of this bad boy, it's just going to be a chain rule. So the outer function is something to the 2/3. So the derivative is going to be 2/3 times that something to the 2/3 minus 1 is negative 1/3. That the inside function stays the same, x squared minus 4. And remember the chain rule, then you have to take the derivative of the inside function, which is 2x. So that's like the f prime of g of x times g prime of x. That's the chain rule. So the x squared minus 4 is the g of x. And the g prime of x, the derivative of x squared minus 4 is 2x. So just a little throwback for you. Which I am going to simplify. 2 times 2x is 4x. The 3 I'm going to put on the denominator. And x squared minus 4 to the negative 1/3, I can bring to the bottom and make it x squared minus 4 to the positive 1/3. Okay, so that's just simplifying the function. Okay. Now, this function, there's no dividing by 0 involved. It's going to be, I can plug any number into this and not worry about having any DNEs or anything like that. It's just x squared minus 4 is fine, and to the 2/3 is fine. In this situation, I want to find out whether the derivative is either 0 or does not exist. So the derivative equals 0 when the top equals 0. Do you guys remember too, when we did implicit differentiation, I said, can you find where there's vertical tangent lines and horizontal tangent lines? We found out whether the derivative is either 0 or does not exist. It was 0 when the top was 0. So in this case, when x is 0. And the derivative does not exist when the bottom is 0. So that's when the 3 times x squared minus 4 to the 1/3 equals 0. If you divide everything by 3, you get x squared minus 4 to the 1/3 equals 0. You can cube both sides to kill off the 3's. So then you get x squared minus 4 equals 0 cubed, which is still 0. So then x squared equals 4. So x equals not just 2 plus or minus 2. Many of people get upset when they miss out on that. So plus or minus 2 does exist in this function. I would just get 0 to the 2/3, which is 0, which is fine. So 0 to a negative 2, these are my critical numbers. Or points, I don't care what you call it. So now we're going to use that to define my interval. So I want to find out where my function has relative extrema. And it's at 0, 2, or negative 2. Now, if there is a relative extrema, it's got to be at one of those 3 points. Doesn't necessarily mean there's going to be 3 of them, but if there is any, this is where it's got to be. So what I'm going to look for is I'm going to see what the function's doing outside of these intervals, whether it's the slope is positive or negative, and if there's a sign change, then we know that there's a max or a min. Right. So if there's a sign change, then there's going to be a min. It's going to be there's going to be an extrema. If it goes from negative to positive, it's a min. If it goes from positive to negative, it's a max. So we need to plug a number less than negative 2 into my derivative. I'm going to use negative 3. So if I plug negative 3 into here, what am I going to get? The top 4 times negative 3 is going to be negative 12, so the top's going to be a negative number. The bottom, if I plug negative 3 in here, negative 3 squared is 9. 9 minus 4 is positive 5. 5 to the 1/3 is positive. Times a positive 3, I'm going to have a positive number on the bottom. So a negative divided by positive is going to be a negative number. So I know this is going to be negative. It ends up being about negative 2.339 for those of you who just want to put in the calculator. If I put in a number between negative 2 and 0, let's try negative 1. 4 times negative 1 is going to be negative 4. So that's going to be a negative on top. If I put a negative 1 in here squared, negative 1 squared is 1. 1 minus 4 is going to be a negative number. So negative 3 to the 1/3 is going to still be negative. Times the 3 is still going to be negative. So I'm going to have a negative divided by a negative, which is going to give me a positive. Okay. And it looks like I got about 0.924 when I did it out. Now, what's the number between 0 and 1? Let's use positive 1. Okay. Is it going to be positive or negative? Well, if I plug in a positive 1, 4 times 1 is going to be a positive number. If I plug in a 1 to the denominator, 1 squared is 1, 1 minus 4 is negative. A negative number to the 1/3 is going to be negative, times the 3 is still going to be negative. So a positive divided by a negative is going to be a negative number. When I did it in the calculator, I actually got about 0.926, which checks negative 0.926, sorry. And then if I plug a number bigger than 2, like 3, I'm going to get, let's see, 4 times 3 is going to be a positive number, so I'm going to get a positive on top. 3 squared is 9. 9 minus 4 is positive 5. 5 to the 1/3 is going to be positive. A positive number times 3 is still going to be positive. Positive divided by positive is a positive. And if I did it in the calculator, I got about positive 2.3 anyways, so that checks out. So this is just like the last problem. The only difference now is, do I have any relative extrema? I will have relative extrema as long as I have a sign change. And from here, my slope is negative, and then it's becoming positive. So right here I have a, let me do this color. There we go. So I'm going to have a minimum at negative 2, and then my function's going from increasing to decreasing. So my slope is positive to negative, so I'm going to have a max there. And then we have another sign change, so my function's going from decreasing to increasing, so I'm going to have another minimum there. Okay. So f has a relative min at negative 2 and 2. So negative 2, comma, and positive 2, comma. What's the value of the function at negative 2 and 2? I just have to put negative 2 and 2 into this function and see what I get. Negative 2 squared is 4. 4 minus 4 is 0. 0 to 2/3 is 0. If I plug in positive 2, 2 squared is 4. 4 minus 4 is still 0. 0 to the 2/3 is still 0. Now, f has a relative max at when x equals 0, comma. If I plug 0 into this function, I get 0 minus 0 squared is 0. 0 minus 4 is negative 4, and I get negative 4 to the 2/3, which I put in the calculator gives me about 2.52. Okay. So that 2.52, if you plug in 0 into the original function, that's 0 squared minus 4 to the 2/3, which is about 2.54 or 52. All right. So again, this is just, everything's going to be very similar, just getting more reps in. We'll do a bunch in class, and I'm going to do one more with you now. Where's it going to, am I doing 2 more with you? I'm doing 2 more with you. Find the relative extrema of f of x. So let's see here. We need to find the derivative. So we can find the critical points to define our intervals. So the derivative here is going to be low d high minus low d high minus high d low over low squared. So it's going to be 4, that's a 3. So I'm going to have 4x to the 5th. Distribute the 2x in, it's going to be a negative 2x I'm distributing, so I'm going to get a negative 2x to the 5th minus 2x all over x to the 4th. 2 times 3 is 4. 4x to the fifth minus 2x to the fifth is just 2x to the fifth minus 2x over x to the fourth. Okay. So let's find our critical numbers. That's where the derivative of 0 does not exist. Sure. So f prime of x equals 0. And that's when the numerator equals 0. So that's when 2x to the fifth minus 2x equals 0. So I factor out a 2x. I get x to the fourth minus 1 equals 0. This is a difference of squares again, right? X to the fourth minus 1 is the same thing as x squared minus 1 squared. So if I do the difference of squares, it's going to be x squared minus 1, x squared plus 1. And the x squared minus 1 is the difference of squares. That's x plus 1, x minus 1. And that's at x squared plus 1 still there. So x equals 0, x equals negative 1, and x equals positive 1. Okay? So that's where the derivative is 0. The derivative does not exist when the denominator equals 0. So that's when x to the fourth equals 0, which is when x equals 0. There's like an overlapping point here, but there's actually a bigger deal about that point here. In my original function, f of x is defined everywhere except 0. You cannot plug 0 into my original function. So these are my critical points. Oops. Negative 1 and 1 are my only critical points. This is not a critical point. We're still going to use 0 in the sign chart. What's happening at 0 is we have an asymptote. If you remember back, this should make sense that we have an asymptote here. So we cannot have a max or a min here. We can only have a max or a min at negative 1 and 1. But we could have a sign change, so we want to make sure we check if there's a sign change or not. Because if you have an asymptote like this, you're going from positive to negative and you have a sign change, even though you don't have a max there. So you got to be careful about that. So what we're going to do is we're going to make a sign chart. And we're going to use negative 1, 1, and 0. Just remember that 0 is not going to be a max or a min, even if we have a sign change. Only at negative 1 and 1 can we have a max or a min. So if I plug numbers into my derivative now, a number less than negative 1, like negative 2. If I plug negative 2 into here, well, the denominator is x to the fourth, so no matter what I plug into the denominator, I'm always going to get a positive number. So I just got to see what's happening at the top. If I plug in a negative 2 to the fifth is negative. It's going to be a bigger negative than this negative 2 times negative 2 is going to be a positive 4, but this is going to be a bigger negative, so it's going to be a minus. So you're going to get a negative. It's going to be decreasing. A number between negative 1 and 0 is negative 1/2. Again, the denominator is always going to be positive, so what's the numerator going to be? I end up getting 15, which is going to be, I end up getting a positive number. So that's positive. So by the way, I got about 15 here. I got about negative 3.75. So if I plug a number between 0 and 1, I'm going to plug in positive 1/2. Again, the denominator is always going to be positive. And if I plug in a positive 1/2, this ends up being smaller than that, so it's going to say negative. So I'm going to have a negative number. And I got about 0.15. And then if I plug in a number bigger than 1, like 2, and the denominator is definitely going to be positive, and the numerator, this term is going to be bigger than that term, so it's going to say positive. And it looks like I got about 3.75, which is positive. So that's what I needed, just to know if they're positive or negative. This is 15, this is 0.15. I have a feeling that I just missed a decimal on my notes. Okay. Where do I have a max or a min? Well, it's either at negative 1 or 1. If I have a sign change, we have a max or a min, and we do. We're going from decreasing to increasing. So we have a min here. And then, although I'm going from increasing to decreasing, this is an asymptote, so it's not going to be a max. No extrema. And then here I'm going from decreasing to increasing, so then we have a min. Okay. So f has no relative max. F has relative min at -1 and 1. To plug -1 and 1 into my original function will tell me what I get. -1 and 1 should give me the same output. -1 squared is 1, or excuse me, -1 to the fourth is +1, 1 plus 1 is 2. -1 squared is 1, so I get 2 over 1, which is 2. If I plug in 1, we get the same thing, we get 2. Okay. This would be a good graph to check out, but because the video is getting long, I'm not going to make you check it out. And I just want to get down to this third example, so you can copy that down. And I'm going to save this one for class. So after you have it copied down, we'll do this one in class together as kind of like a warm up into the practice problems we're going to do in class. All right, so again, don't forget to feel free to like, share, and subscribe. Ring the bell for notifications. And if you want more, let me know in the comments. If you'd like to further support the channel, I suggest trying to follow me on my other channel where we